Hello everyone. In today's session, we are going to cover how to use Helm lint, Helm debug, dry run, and Helm template with examples. Helm, the Kubernetes package manager, empowers developers and operators in streamlining application deployments and managing Kubernetes resources efficiently. Among its arsenal of commands, three stands out as indispensable tools for ensuring smooth deployments and maintaining chart integrity are lint, template, and dry run. So this is our table of contents which we are going through. First is prerequisites. You should have AWS account with Ubuntu EC2 instance. Then you should have Minikube and kubectl installed. Also, you should have Helm installed. I already have Minikube and Helm installed on my Ubuntu EC2 instance. You can follow this official documentation or you can watch our previous video. So let's move forward. Next is Helm lint command use case with examples. So what is Helm lint? The Helm lint command is used to check a Helm chart for potential issues or errors. It performs a series of checks on the chart structure, syntax, and adherence to best practices. Here are some common use cases for using Helm lint. Validate chart syntax. Helm lint checks for syntax of your Helm charts file, ensuring that they are correctly formatted and follow the expected syntax. This helps catch issues such as YAML syntax errors or misplaced template directives. Second is check chart structure. The command examines the overall structure of your Helm chart to ensure that it adheres to the required conventions. It verifies the presence of necessary files and directories such as chart.yaml file, templates directory, and others. Third is verify template rendering. Helm uses templates to generate Kubernetes manifest based on the provided values. Helm checks if the templates in your chart can be rendered successfully, catching potential errors before deploying the chart to a Kubernetes cluster. Fourth is ensure chart best practices. The command enforces Helm best practices and guidelines, helping you maintain a consistent and well-organized chart. It may provide warnings or errors for practices that could lead to issue during deployment. Prevent common mistakes. Hemlint helps prevent common mistakes and pitfalls by identifying issues in your Helm chart early in the development process. This includes detecting misconfigurations, missing required fields, or other problems that might cause deployment failures. The Hemlint command is used to validate your Helm charts and detect potential issues or errors before deploying them to a Kubernetes cluster. This command takes a path to a chart and runs a series of tests to verify that the chart is well formed. If the linter encounters things that will cause the chart to fail installation, it will emit message. If it encounters issues that break with convention or recommendation, it will emit warning messages. To use Helm lint, navigate to the directory containing your Helm chart and run the following command. The command is Helm. You should replace the dot with the path to your Helm chart if it's in a different directory. If there are no issues, the command will display a message indicating that the linting was successful. And if there are problems, Helm will provide information about the errors or warnings encountered. Now let's see the example. First, we will create a chart named world Helm using Helm create command. You can give any name you want to the chart. Let's create a chart named world. Our chart is created. Then we will use Helm command to validate the chart. Our linting is successful. The linting indicates that Helm is linting the current directory where your Helm chart is located. Info chart.yaml icon is recommended. This is an informational message suggesting that it's a good practice to include an icon in your chart.yaml file. It's not an error, but just a recommendation. One chart linted and zero chart failed. This line informs you that the linting process completed successfully. There were no failures or errors found in your Helm chart. This output shows the successful validation of the chart, which we just checked. This command will analyze your chart files, templates, and values for any potential issues or errors. And if everything is correct, you will see a message indicating that the linting was successful. And if it's failed, it will give error and warning. Now let's see what will happen if there is an error. We will modify the values.yaml file. First, navigate to the world directory by using following command, which is cd world. The cd command is used to open a directory. Then we will modify and simply delete the lineage from values.yaml file using following command. The command is nano values.yaml. Our world directory is open. Now let's open the values.yaml file. Command is nano values.yaml. Now let's delete the image line. Press Ctrl plus X, then Shift plus Y and hit enter to save the information. Now exit the directory using the following command cd. Then again run the helm command. Now let's exit the directory. Now run the helm command and our chart name, which is world, and it gives us an error. The error is values.yaml unable to parse YAML, error converting YAML to JSON. YAML line 6 mapping values are not allowed in this context. It indicates an issue with the structure of your YAML file. So it says one chart linted and one chart failed. So this is the error message given after the linting. The YAML file is case sensitive, so you need to make sure that there is no indentation missing or syntax errors. If there are errors or warning, you will receive feedback about what needs to be fixed. This is shown in the below image. Now let's move forward. Helm template command use case with examples. The Helm template command is used to render the Kubernetes YAML manifest from a Helm chart without installing it on a cluster. This is useful for inspecting the generated Kubernetes resources before deploying them to a cluster. Here are some common use cases of Helm template. First is preview manifest. It use Helm template to generate the Kubernetes YAML manifest based on the Helm chart. This allows you to inspect the resources that will be deployed to the cluster without actually applying them. The syntax is Helm template, then your release name, chart name, hyphen f values.yaml. Replace the name you want to give to your Helm release, and for chart name, you can replace the name you want to give to your chart, hyphen f values.yaml. This option is used to specify a values file that contains customized configuration for your Helm chart. It allows you to override default values specified in your Helm chart. Second is debugging. When encountering issues during Helm chart deployment, you can use Helm template to examine the rendered manifests. This helps in debugging and identifying any problems with the generated Kubernetes resources or values. Third is version control and auditing. Its syntax is Helm template, release name, and chart name, hyphen f, values.yaml, output.yaml. You can replace the release name with the release name you want and chart name with the chart name you want. Again, hyphen f, values.yaml file. This option is used to specify the values file, and output.yaml indicates it direct, direct, redirecting the outputs to a file named output.yaml. So the output of your Helm template will be stored in this output.yaml file. Fourth is customization and overrides. It previews the manifest with different configurations and overrides by specifying a different values file or using the hyphen hyphen set option to dynamically change values. Its syntax is Helm template release name, chart name, hyphen hyphen set key1 equal to value 1, comma key2 equal to value 2. So here hyphen hyphen set key1 equal to value 1 and key2 equal to value 2. This part allows you to set values for specific parameters in the Helm chart. Helm chart often include a values.yaml file where you can define default configuration values. The hyphen hyphen set flag lets you override these values on command line. Fifth is integration with CI/CD. In a continuous deployment pipeline, you might want to use Helm template as a step to generate the Kubernetes manifest. Before applying them to the target Kubernetes cluster, this allows you to perform additional checks or validations before actual deployment. Sixth is security and compliance checks. Before deploying a production environment, use Helm template to inspect the generated manifest and perform security and compliance checks. This ensures that the deployed resources adhere to your organization's policies and standards. The Helm template command takes a Helm chart as input and processes its templates which are written in the Go template language. It replaces placeholders in the templates with actual values and generates the resulting Kubernetes manifest files. These values are taken from the values.yaml files. Now let's see the example. First, we will create a chart named demo using Helm create command. You can give any name you want to the chart. Okay, let's create a chart named demo. Our demo chart is created. Then we will use Helm template command to inspect the rendered YAML. And it will show us all the YAML files present in the chart, which are test connection.yaml or deployment.yaml, service.yaml, service upon that.yaml. All these files are displayed here in the output. You can even change the values in values.yaml file. First, navigate to the directory cd demo. Then open the values.yaml file using nano values.yaml syntax. Our values.yaml is open. Then change the image repository shown below. The image repository name here is DevOpsInt/Node app. Let's copy it. We change the image repository name. After modification, place Ctrl+X, then Shift+Y, and enter. Our values.yaml file is saved. Then let's modify the deployment.yaml. So navigate to the template directory using the cd template command. Cd templates. Then open the deployment.yaml using nano deployment.yaml file. Our deployment.yaml file is open. Now change the API version. Here API version is apps/v1. Change it to the v2. Save it using Ctrl+X and Shift+Y and hit enter. Exit the directories using the cd command. And after that, run the template command again. So let's exit the directories. Now run the helm template demo command. Now here in deployment.yaml, you can see the API version is changed successfully, where in the first part it was the v1, now it's v2. And also your image is also changed, which is DevOpsInt/Node app. Before it was Nginx. So you can also change the default YAML values if you use correct identification and syntax. Now let's see what will happen if there is an error. We will do the same steps like lint, replacing the word with demo, which is our chart name. Then run the helm template command again. Now let's follow the previous process again. First, Open the demo directory, then open the values.yaml file using nano values.yaml command. Delete the image line, save it using Ctrl plus X, then Shift plus Y and hit enter. Exit the directories before running command. Always remember this. Use CD to exit all the directories. Now run the Helm template demo command again. Now it will throw an error. So what's the error? It cannot load values.yaml, error converting YAML to JSON, YAML line 7 mapping values are not allowed in this context. Indicates an issue with the structure of your YAML file. Now let's see the Helm debug dry run command use case with examples. The Helm debug dry run command is used to simulate a Helm release without actually installing anything on the cluster. It's a useful way to preview what changes Helm would make to your Kubernetes resources without affecting the actual cluster. Preview Helm chart changes. When you run Helm debug dry run, Helm goes through the process of rendering the templates in your Helm chart and applying values, but it doesn't actually perform the deployment. Second is syntax and template checking. The dry run flag allows you to catch potential errors in your Helm chart templates or values without making any changes to the live Kubernetes cluster. This is useful for verifying the syntax of your templates and ensuring they can be rendered correctly. Third is check configuration and resources. It helps you to check if the configuration values you provided are being correctly applied to the Helm chart and whether the resulting Kubernetes resources are as expected. Avoid unintended changes. Using dry run is a safety measure to prevent accidental changes to your Kubernetes cluster. By previewing the changes, you can make sure that you are deploying the right configuration before actually applying it. Syntax for it is helm install hyphen hyphen dry run hyphen hyphen debug, then your release name, chart name hyphen values.yaml. Dry run simulates the installation without making any changes to the cluster. It makes sure that installation is dry run, meaning no changes are actually made to your Kubernetes cluster. Then debug prints the generated Kubernetes manifest to the console for inspection. The release name is the name you want to give to your Helm release, and chart name is the name or path to the Helm chart. Hyphen F values.yaml, it specifies the values file to override default configuration. Now let's see the example for the debug dry run. First, we will create a chart name hello world using helm create command. You can give any name you want to the chart. Now our hello world chart is created. Then we will run the helm install debug dry run command. where we release the name HW. You can give any release name you want. And it will give us the information about the chart. Here is the release name, which is HW, which we given. Then it tells about the last deployed Friday, December 8. Then its namespace is default. And this is the main part. Its status is pending install, which means the chart is not installed. And we can check what will happen when we install the chart without actually deploying it on the Kubernetes cluster. It also gives us the all the template values. And lastly, it also gives us the node, like get the application URL by running this command. This command will output the generated manifest to the console without actually installing the chart along with nodes. You can use this output to verify that the generated manifests are correct. So this is the output. And if there's an error, then it will not simulate a release install. To see that, we will follow the same steps used as grid and template. After exiting the directory, run the following command, which is helm install hw debug dry run hello world. First, let's follow the previous steps. We will clear command there the page. First, open the hello world directory. Then use nano values.yaml command. Our values file is open. Now again, let's delete the image line. And also, if you want, let's delete the replica count to save it using Control plus X plus Y, then hit enter. Now don't forget to exit the directories. Use the cd command. Now let's run the dry run command, which is helm install hyphen sorry, our release name is HW, then hyphen debug space hyphen try hyphen run, and our chart name is hello world. And it will throw an error. Here it gives the error installation failed at template hello world templates test connection.yaml 14 rows 16 column executing the hello world templates test connection.yaml. So you can see what error is happening. You can correct the file. So before actually installing the chart to your Kubernetes cluster, You can use the dry run command to verify if our chart is built correctly or not. There are no errors, no syntax or indentation errors. Similarly, you can use Helm upgrade debug dry run, which simulates the upgrade of an existing Helm release without applying the changes and allows you to preview the modification before executing an actual upgrade. Now first let's correct our file cd uh, hello world. It will open our hello world directory. Then open values.yaml file using nano values.yaml command. Refresh the values as it is, then save using control plus H, shift plus Y, hit enter. Now we corrected our values.yaml file, exit all the directories. Now first install the Helm chart using following command. Command is helm install hw hello world. Our installation is successful. Where it says status is deployed. When using dry run, it was pending. Now let's modify the values.yaml file. Navigate to the directory using following command, which is cd hello world. Then we will use nano values.yaml file and edit the values. We will edit a replica count equal to 2 and write with message. The message will be message hello world. This is customized message. So let's edit it. Change the replica count to 2 and write the message just below it. Save using control X plus Y and hit enter. Now exit the directories using cd command. So now we will perform Helm upgrade dry run. Let's copy Helm upgrade HW debug dry run hello world command. Paste it and it was successful. Here, as you can see, it shows the release name, which is HW, the last deployed date and time, then namespace, which is default, and its status is pending upgrade. If we use just Helm upgrade without using debug dry run, then here will be upgraded and the revision is 2. As you can see, the message here is displayed. Hello world. This is customized message. The output is also given here in this article. This will simulate the changes without applying them. It's a way to preview the changes that would be made without making them. Now let's see the comparison of Helm lint, Helm debug dry run versus Helm template command. The purpose is for Helm lint, it's to check Helm chart validity. Helm template purpose is to generate Kubernetes YAML, and dry run will simulate a release install. Execution can be done by the using Helm lint and your chart name command, and in Helm template, the Helm template and your chart name command, and in Helm install, your chart name and dry run command. The output will be console output in Helm lint, and in Helm template, it will be in the form of rendered Kubernetes YAML files, and a dry run will display the installation info. There is no actual installation in Helm link, and in Helm template, it shows the rendered Kubernetes YAML, and also in dry run, there is no actual installation. The Helm link will check for errors and warning, and there are no error and warning checking in Helm template and dry run. Helm link validates the star structure, and there is no validation performed in Helm template and dry run. Customization is not allowed in Helm lint, where in Helm template and dry run, values can be overridden. Helm lint can be useful for debugging. It identifies the chart issues. Helm template can inspect the rendered YAML, so it is also useful for debugging. And Helm dry run also check the install output, so it's also useful for debugging. The table provides a concise comparison of key Helm commands, which are Helm lint, Helm template, Helm install, dry run. Each command serves a distinct purpose in Helm workflows, helping users generate Kubernetes manifest, check for issues in Helm charts, and simulate installation or upgrades without making actual changes to the cluster. So in conclusion, in summary, while Helm template and Helm install dry run focus on rendering YAML and simulating installation, Helm lint specifically targets chart validation, ensuring that the Helm chart is well structured and follows best practices. Each of these Helm commands serves different purposes, and their combined use can contribute to a smooth Helm chart development and deployment process. Together, these Helm commands can help you improve the quality of your Helm charts and troubleshoot complex Kubernetes issues. Thank you.